slope have to do with y-intercept or vice versa?
I know how you can use it, but you're saying how it is.
Yeah. You know what I'm saying? Yeah, but I'm getting that. It's all on.
If you know what y-intercept is, then you can use the slope account to get to
That's how you do the gradient, right? But
Yeah, that's the only thing, but I don't know what else.
Y-intercept is the slope.
Square root, square root.
Yeah.
let's say what's the difference between these two lines?
Parallel opposite.
The y-intercept is different, right? This line has y-intercept 0, 1. This line has y-intercept 0, minus 1. So what about their slopes? They're the same slopes, right? In both cases, the slope is 1. What happens if two lines have the same slope? Parallel. Okay. So if I were to graph these two lines, I would like something like this. The reason why I bring this up is, what does the y-intercept have to do with the average rate of change? Nothing, right? The way, so you could interpret this in terms of, say, speed, like we had in that problem before, is the y-intercept is where I start. But how does where I start determine how fast I run? It doesn't, right? I run and however fast I run. So, someone had mentioned with that problem that I talked about before, finding the average speed, like the thing that was confusing was that the y-intercept was 0. Because like, kind of, you don't really see that the equation has a form like this, x plus b, because the b is missing, right? If you're looking for a b, it's not there. That's confusing. But the point is, what is the question asking for? It's really the slope. The slope is independent of the y-intercept in the same way that the speed that I'm running at is independent of where I start running. I mean, to completely determine my position, I need to know both speed and where I started. But if all you want to know is how fast am I running, it doesn't matter where I start. If all you want to know is the slope of the line, it doesn't matter where the y-intercept is. The slope
You gotta put your
is
password in first, I'll go ahead. And
so
then
that was an interesting point I thought I would share since it came up. Last time. Any questions? This is what I said, kind of weird. So now let's talk about standard form of
X
these.
squared,
What's that?
ax squared plus bx plus c.
What's so great about standard form over some other form?
It's not hard.
Well, so
Can
it's easy to find the roots. Well, first off, it's really easy to find the y-intercept, right? Why? Why is it really easy to find the y-intercept?
Y equals 6.
So where is the y-intercept? Where x is 0. You plug in x equals 0, and those two things are gone, right? So let's just find the y-intercept. It is 0, C or C. Depending on whether you want to answer as a point or just a value of y. So it's also relatively easy. Why? What's the sort of fact that makes it sort of easy to find the roots? Do you know what I mean by when I say roots? What do I mean? No, I mean find the roots of the equation. When you set it to 0. Why? Is that kind of easy?
Could you use quadratic formula, or you could use
That's what I'm looking
factoring?
for. Just a quadratic formula. One other thing that's kind of useful about this form that it's not a big deal, but this makes it obvious that the equation is quadratic or second degree polynomial, right? But you can just see right out front what's the leading power of x squared. So you see, easy to see. There you go. What's not so great about this version?
The quadratic is?
Yeah, about like writing a quadratic function or a parabola in terms of this form. How easy is it to graph this? I mean, you know the y-intercept, but what other kind of information does this give you about the graph of a nothing,
You
right?
have to the direction, right?
The only thing you
Tells you
know,
the direction, whether
Yeah.
it's gonna be positive,
the only thing you know is that. So let me make a note of that. Any quadratic function has graph one. How do you know if it opens up or down? You look at the leading coefficient, right? Does everybody understand what I mean? By leading coefficient, I mean the number in front of the square, right? The number in front of the highest power. If it's positive, the thing opens out. Up. If it's negative, it goes down. So, but other than in terms of the graph, other than in terms of opening up or down and the y-intercept, this form doesn't really say a whole lot about the graph. So how else can you write equation for
In vertex form, so it's called.
what is that? How do you get from here to here? Standard form. Section. Right.
And we take half of the coefficient of the x.
So you
No,
gotta-
she did.
That's what
I don't even know what we're doing.
X minus 2 squared plus 2.
And it's because when you factor that, you get x squared.
Oh, that's right, because I have.
You'll have to right subtract the 4.
And then if it wasn't, your dad used to factor. So 2, 2, if it was like 8.
Like there's an 8x.
I have no idea what we're doing. I'm trying to. So it makes some sense. It's not.
What did you add?
This would be K.
Yeah, so that's the problem. Then I think that's probably most people, because that's not.
That's.
'Cause remember, what do you do to complete the square? You add and subtract something.
X minus plus
again, there's a process that you have to go through, right, to get from here to here. And that process is completely square. So what do you do?
So I take out the x, since there's nothing there, so it would actually be 1. And then I get x there.
Easier, isn't it easier to take out -1?
But you don't need it. I mean, there's not really anything to do in terms of that. You don't need to pull out a negative because it's just 1, so there's nothing to do.
-2. And then what do I do with the 2?
If A is anything but 1, you have to factor it out, but A is just 1, so there's.
So
The end state
out equals.
So let me go through this. So I'm in standard form, right? The first thing you do is look at the leading coefficient, the A. If A is 1, move on. Right? If A was something else other than 1, you would factor that out of all 3 terms, right? But A is 1, so there's nothing to do there. Okay. The next step is you look to see what B is. Okay. What is B? 4. It's -4. So you want to take B over 2 and square it. So here you told me B is -4, so it's -4 over 2. -2, so you square that and you get 4. So what you want to do is add and subtract 4. Why? Because the goal here is to turn this part into a perfect square. So what is a perfect square?
Still that is +2, so it's still x -2 squared +2.
Yes.
So subtracted 4.
So a perfect square has this form, and if you flow it out, x squared is -2s
Just 4
plus
Then you
s
take
squared.
that x minus 2 x squared.
Yeah, sorry.
X minus 2 squared. Here. Switch out.
Right.
So that's that.
So this is what I want to achieve by completing the square.
Minus 2.
You're guaranteed to get that if you take half of the first order coefficient and then square it. So that's what I did. I take half of -4, -2, square that, get 4. Add and subtract. Why do I add and subtract?
Because you're adding in 4.
Because I'm adding 0, right? And the only thing you can do and not change the original equation is to add a 0. So now, is this a perfect square? So it has this one here? It does, right? So I can write this as x minus 2 squared. I get a minus because that's a minus. All this becomes this. And then -4 plus 2 is -2. That's the vertex form. Questions?
Because the vertex there, +2, +2.
Positive 2, negative 2.
+2, negative 2.
Yeah, so that's what I want to talk about next, but, so the vertex, notice there's a built-in minus sign here. This is plus, the vertex is point H, K, right? here at the vertex would be a +2 here, and a -2 for the y-value. How can you check and make sure that what you claim is the vertex really is the vertex?
I was gonna say graph there.
Just plug it in.
Oh.
Plug this in here. Plug, if I plug in 2 for x, do I get that y value? So I plug this in, that's gone, right? And I'm left with y minus 2. So that's how you know that that's the right vertex. So you should always check. So y. Why is that not the vertex for that guy? We'll plug in 2 for x. So y equals 2 minus 2 squared minus 2. That goes away. I'm left with -2. Does that agree? No, it does not. So, you know that can't be the vertex. In fact, it's not even a point on the graph of that thing, right? Because it doesn't satisfy the equation. Everybody follow? I mean, no, it's just
Take much
for
longer.
everybody to understand everything.
I'm just trying to look back at it. Because didn't we do where we put it over to the other side, right?
So that, when we did that, this.
'Cause that's what
that
I'm
minus
looking
4
at.
right there.
Right.
We put it here and
Right.
then moved it over.
Right.
So it was a 6,
That's
so it's
what
still
I'm-
that balance.
Right.
So whatever you do to one side, you do to the other.
Right,
and
that's
then
why I
you
was
solve
getting,
for y.
I didn't, all my stuff is written the way it should be, so I was
Yeah.
just trying to figure out.
So it kind of depends on what you're doing, but you can also use the plain square to solve an equation, right?
Right.
But here I don't have an equation, I have a, well, I mean, it is an equation, but what I really want is
I mean, how
the
do I-
right hand side. Yeah, you can do it either way. Okay, so what is cool about vertex form over the standard form? It's easier to graph. Why is it easier to graph?
Because you can just plot your vertex, plot your y-intercept. And then you know what, you have to base your side.
You know what goes on.
Well, you know the thing's got to have a graph of a parabola. Why? Oh, because it's a quadratic function, right? Any quadratic function has a graph whose a parabola. So I also still have a, right? So I know if it goes up or down. So I know it goes up or down, and I know what the vertex is. So you just put the vertex there, and then all the things go either up or down. So can I erase this? Vertex form. Right, to just plot the vertex and then draw a parabola. This, of course, is assuming that our A is positive. Okay. what's not so great about is there any information that's not that easy to get from either the standard form or the vertex form? Is there any information that's not that easy to get from either the standard form or the,
Directly, to get
yeah,
directly.
like what can you not just read off immediately?
We'd like to know the x-intercepts, is that included?
That's what I want to look for. The x-intercepts, right? There's no way to just read off the x-intercepts from either one of these. I mean, you could get it from this. What do you have to do to get an x-intercept? Yeah, you have to
Zero for y.
set y equals 0 and then solve one of these two equations, right? Is that always possible?
Once you get imaginary roots. It just means it doesn't cross the x-axis, you can still grab it, it just doesn't cross the x-axis. So the
Okay, so I can
example
have-
that you have on the board actually is an example where it doesn't.
So I can have a parabola that looks like this, right? How many x-intercepts? One. I can have a parabola that looks like this. How many x-intercepts? 2. We have a parabola that looks like this. How many x-intercepts? Okay. So, what does that tell you about the quadratic equation? The number of roots to the equation, right? So this has no real roots, right? This has 1 repeated real root. This has 2 distinct real roots. So if I have quadratic equation or quadratic function, and I'm in one of these two cases, what can I do?
Accurate. Or you
Factor, right? So if we have let me just say if we have real roots. We can factor this. X minus, let me call it S and T, where S and T are the roots.
And they have to come in pairs, so you can't have one real and one non-real root.
It's possible for them to be the same, right? Or S and T could be equal, in which case we would be in this situation with 1 real root.
So you're saying roots are the true numbers within the thing?
Yeah.
They're also x-intercepts.
Right.
An x-intercept and a root are the same, it's just a different term.
So it's either the x-intercept or when the right-hand side is 0, or when y is equal to 0. Got it?
Yeah, so when it asks you for the roots, it's asking for the x-intercepts when y is equal to
So
0.
there you would do the whole thing and then whatever, plus or minus square root of something. And you
You
know
could-
that there's 2 because there's an estimate table.
Right.
And you could factor it. Like, you could just look at it and see if it's perfect, you know, a trinomial, you could factor it. Or you could just complete the square, just like we did done. Or you could use quadratic formula also.
whichever way is easiest.
So sometimes we say this is in reduced form. So if I can reduce it into a product of, what do we say, linear factors, then what's obvious?
So that again.
It's just the opposite, like that it would be positive S, is that what you're asking?
If I can write, so say for example I have,
Be positive S and a positive T, or I don't know.
suppose you have that, right?
Yeah.
That's a quadratic function, is it not? Why? Because if I FOIL this out, we get something of that form, right? Okay. If I have this written in this form, what information can I read off immediately? The x-intercepts. That's what I'm getting at. So if you can factor, I'm gonna notice parameter right here. If I can write a quadratic equation in factored form, then I can immediately tell the x and y intercepts, which means I can also graph the thing, right? Because again, you can tell this whether it opens up or down. If there's no negative term here, then it's going to open up. And you can also tell where it's going to pass through the x-axis, so you just draw a parabola opening the right way and then passing through those x-axes. But you can't always do this, or you can't always do this, because I can always complete the square. You can't always factor because it may not have any real roots. So it's kind of a lot of information in it. Just trying to tie together all the sort of important things about quadratic functions. Suppose I have a quadratic function whose graph is a parabola like this. This function clearly has a minimum value, does it not? This function here clearly has a maximum value. So how do you know when, or for what value of x you have a min or max, and what the max or min value is? Yeah, the vertex. So the vertex. The max or min value. How can you tell immediately if you're going to have a max or a min, which one it's going to be? I mean, right. If it's positive, the thing's going to open up, and so that means it's going to have a minimum, and vice versa. So if we look at that equation we had before, this has a minimum value, right? What is it, and for what value of x does it have, does it occur?
Is that still the negative?
Yeah, so we already found that this was I could write it in vertex form, x minus 2 squared minus 2. So where does the minimum occur?
That's minimum of -2.
a minimum value. And that's
And it
the y
occurs when-
value.
And that occurs when x is equal.
Good. Okay. So, in terms of using lines and quadratics to model some kind of thing or another, like we saw, for example, using a line to model the relationship between position and speed, or position and time, right? You could maybe do something similar with parabolas. Okay. Lines are cool because you can tell right away by the slope what the average rate of change is. So, in general, for general functions, that's not easy to do. You can't tell right away. Now, I can't tell what the average rate of change is for a quadratic, but I can tell easily, without too much work, what the maximum or minimum value is. In general, determining maximum, minimums, and minimums for functions is difficult. So, for lines and quadratics, there's information that's valuable, that's easy to determine, that for more general functions is not easy to determine. You know what I'm saying? That's something important to keep in mind, okay? In general, it's not easy to determine the average rate of change of a function. For lines, it's easy, it's the slope. In general, it's not easy to determine the max or min values of a function. For quadratics, it's easy, it's just a vertex. So, I think I have a problem that I. Okay, let's just try one more of these then. So first off, what kind of problem is this? What's the sort of underlying thing? Quadratics, right? And what are you going to do in order to find the max or min value for quadratic? First off, is it going to have a max or a min?
Maximum min.
It's going to have a min. Why is it going to have a min? The leading coefficient is positive, so it's got to open up, right? So this is going to have min. And now it just remains to figure out what that minimum point is by doing what? Weighting the square and determining the vertex.